This is the spec for the module on even and odd integers. Even and odd integers. And the whole idea here is to make sure students understand what the product or the sum of even or odd integers are. So first of all, the choices will always either be even or odd. So we're going to present them with an expression with some information, and they have to pick whether that expression is going to be even or odd. Even or odd, and you're not going to see those right there. So it'll be kind of a new question type, not 5 choices, only 2. So a question could be of the form, and feel free to add some creative flourish here, but a question could be of the form, n is even and m is odd. And then we could have statements of the form n times m is question mark. And they'd have to pick whether it's even or odd. It could be like that, and in which case you could say, if this was the question, you could say, and when they click hint, the hint would be n even times n odd is an even times an odd is even. Or even better, we can write an even times, or in parentheses, we could write an even times anything is even. And of course, you have other combinations here. You have if they are both even, and then you would just say an even times anything is even. Or you have the situation where they're both odd. And if they're both odd, then of course the hint will be an odd times an odd is odd. Now, all of the questions aren't just going to be two numbers here where n is even and m is odd. We might have things of the form. Let me clear this. And we would just want to make sure people really understand these notions. We just kind of tested the understanding of multiplication, but we want this module to test multiplication of odd and even, addition and subtraction of odd and even, and combinations of them. So let me show you what I mean. So let me clear this. So we might say something like this. We might say n is odd, m is odd. And then you could have a statement where it's something like 4 times n plus m is question mark. And of course, the answer here, well, I'll give the answer in the hints. The first hint that we would give, we would say, well, 4 times n is even because 4 is even. And we could have put any random even number here, and so we have a lot of variety in problems. But 4 times n is even because 4 is even, and an even times anything is even. And an even times anything. Anything is even. And then you could say, the next hint would be 4n plus m is odd, since 4m is even and m is odd, and an odd plus an even is odd. And then we're done. And then, of course, the correct answer over here would be odd. Now, we could do other things, like, let me do one more example. I think you'll get the point. And feel free to do various combinations of everything that we're talking about here. Let me clear this. We could do, let me clear it. We can even kind of go as fancy, and I'll leave it up to your discretion how fancy you want to get here. But it could be things of the form, n is odd, or it could be even. Maybe m is even, and then maybe we have p is odd. And then we give them reasonably complex expressions. We could say n times, we'll use the dot for multiplication, n times p n times p minus m plus m, or let's do it this way, plus p is, and something like this is a little bit more complicated. You don't have to go fully here, but this would be cool if we could get to this level of complexity. And feel free to play with it, where this could be a plus or a minus. Well, we should always do multiplication. Division makes things a little bit complicated. So we'll always do multiplication, addition, and subtraction. And, for example, the hints here would be n times p is even, since, and we've gone over this argument, since an even times anything is even, since we've seen that before. And then we'll say n times p minus m is even, since it is an even minus an even. And I won't have to write all that there. And then we'll write n times p minus m plus p is odd, since it is an even times an odd. Now, or even plus an odd. Even plus an odd right there. Now, this is, I view, kind of the base level of implementation. If we wanted to get fancier here, the hints actually could directly mark up the expression. And this would kind of be, if we have the time and we want to do the ideal implementation of it, it'll be harder to implement. But when someone clicks hint the first time, instead of writing the hints in text below, it could go directly onto this expression. And it'll say, even, since it is an odd times an even, since odd times even. And then you click hint again, and it'll say, so we have an even, it will say even, since it is an even minus an even. And then they click hint again, and it'll say that this whole expression, we will say it is odd, since, and we could even color code it if we want to get fancy, odd plus, or since even plus odd, since even plus odd. So this one would be a little bit more difficult to implement. It's a little bit more visual, but if there is a capability, this might be a better way to explain it. We could even have these so it really lines up with the expressions. But a base case will just be text bullet points. They don't have to actually have the bullet points shown. I just did that for this explanation, where it just gives the overall logic about why this expression is odd.